So today we're going to look at comparing and ordering fractions and mixed numbers. And there's more than one way to do this. Probably when you were first learning about fractions, you learned to draw models and compare using pictures. And that works well in some cases. As long as the fractions are far enough apart and your pictures are pretty precise, then you should do fine with that. But there are other ways that are a little more efficient and where you don't have to be so careful in your drawing in order to do them. So one of those ways is to make like fractions. Now remember, like fractions mean they have to have the same denominator. So if we want to compare, for example, 3/4 and 1/3, we need to find a denominator that both 4 and 3 can go into. One way you can always find a common denominator is to multiply those denominators. 4 times 3 is 12. So we could use 12 as a common denominator. If we do that, then remember how we make equivalent fractions. We can look at the 3/4 and say, well, how do I go from 4 to 12? Well, I have to multiply 4 times 3 to get 12, and whatever I do to the bottom, I do to the top. So 3 times 3 is 9. So that means 3/4 is equal to 9/12. If we look at 1/3, I can do 3 times 4 to get 12, and so I need to do the same thing to the numerator. I need to multiply by 4. So in this case, 1/3 then is going to be equal to 4/12. So now I can easily compare those. Since 3/4 is equal to 9/12 and 1/3 is equal to 4/12, I know that 9/12 is greater than 4/12 because since the denominators are the same, I can just compare the numerators. 9 is greater than 4, so 9/12 is greater than 4/12. What that means is then that 3/4 is greater than 1/3. So I can always use a common denominator to compare fractions. So if I look at these two examples, try these two on your own and see what you come up with. And when you're done, pause while you're trying it, and when you're done, hit play and see if you are correct. All right, so for the first one, 4/5 and 7/10, I would have used 10 as a common denominator. It's okay to use one of the denominators you already have. So 7/10 can stay 7/10. 4/5 needs to become 8/10. Since 8/10 is greater than 7/10, that means 4/5 is greater than 7/10. So now I want to compare 7/12 and 7/10. And to do that, yes, the numerators are the same, but the denominators are different. So I can't compare and say they're equal or anything like that. I need to make them have the same denominator. I could do 12 times 10 and get 120, but the thing about that is I actually have a smaller one that I could use, 60. And that's just going to make my mental math a little easier maybe. 12 times 5 is 60. 7 times 5 is 35. 10 times 6 is 60. 7 times 6 is 42. 35/60ths is less than 42/60ths, so that means 7/12 is less than 7/10. Looking at a few more examples, 3/4 and 5/6. Again, I could use 24 as a common denominator if I want to, since 4 times 6 is 24. But I might even think of a lower common denominator, which is 12. Now, the way I usually find my common denominator is I choose my bigger denominator, which is in this case is 6, and think about multiples of 6. 1 times 6 is 6. 4 and 6 don't both go into that. 2 times 6 is 12. 4 and 6 do both go into that. So that's my common denominator. 6 times 2 is 12. 5 times 2 is going to give me 10/12. 4 times 3 is 12. 3 times 3 is going to give me 9/12. So since 9/12 is less than 10/12, that's going to mean 3/4 is less than 5/6. I can use this same method to compare mixed numbers. Now, oftentimes people think they have to change those to improper fractions first. No, you don't. 1 2/3 and 1 5/8. Since the whole numbers are the same, all I really need to do is compare the fractions. So I'm going to compare 2/3 and 5/8 the same way as I would if the ones weren't there. So I might find a common denominator of 24, and I'm going to get 16/24 and 15/24, and just copy the 1 over. 1 and 6/24, 1 and 15/24. Since 1 and 16/24 is greater than 1 and 15/24, 1 and 2/3 then is greater than 1 and 5/8. Now my last example here, 2 and 4/7 compared to 3 and 5/8. When I look at this one, the whole numbers are different. So if the whole numbers are different, then when I look at the fractions, if those are both proper fractions, which 4/7 and 5/8 both are, then since 2 is less than 3, that means 2 and 4/7 is less than 3 and 5/8. I don't even need a common denominator. So there is one more method, at least, for finding or for comparing fractions. It's called cross products. Some people might call it shooting stars or butterfly or lots of different names, but the mathematical name for it is cross products. You are cross multiplying, meaning multiply diagonally, and then you can compare those answers. So that literally means starting from the denominator, do 10 times 5, which is 50, and then do 8 times 7, which is 56. When I compare those two denominators, 50 is less than 56, so I can just take that same symbol. Here are my cross products. I can take that same symbol and know that 5/8 then is less than 7/10. Looking at another example, 3/5 and 4/7. 7 times 3 is 21. 5 times 4 is 20. 20 is greater than, or 21 rather, is greater than 20, which means that 3/5 is greater than 4/7. Now, you may say, oh, that's all well and good, but that just seems like magic. Well, there's a reason it works. If I use both methods to compare 2/3 and 5/8, I think you'll see why. Take a moment to do that. Pause while you do that, and then when you're done, hit play and see if you can figure this out. All right, so if I used a common denominator, I should have come up with the fractions of 16/24 and 15/24, because I did 3 times 8 and 2 times 8, 8 times 3, and 5 times 3. Using the cross products method, my cross products ended up being 15 and 16. There's no coincidence that cross products works. In both cases, we found out that 2/3 was greater than 5/8. And the reason why this works, if you look carefully, you're going to notice that just like I'm doing 2 times 8 to get 16 on the common denominator method, I'm doing 8 times 2, which is the same as 2 times 8, on my cross products method to get this 16. And just like I'm doing 5 times 3 to get 15, which is my numerator with for 5/8, I'm doing 5 times 3 or 3 times 5 and getting 15 as one of my cross products. So really, when you're doing cross products, what you're doing is finding the numerators without actually having to find the common denominator. So it's a little bit quicker and shorter of a way to do it. Now, I can use all of these skills together to put fractions in order. So I can either change all my fractions to like fractions and then compare them, or I can use cross products. So for 2/3, 5/6, and 3/4, if I want to put those in order from least to greatest, if I use a common denominator, I should get 6 is my greatest denominator. 1 times 6 is 6. 3, 6, and 4 do not all go into that. 2 times 6 is 12. 3, 6, and 12 all go into that. So I'm going to use 12 as a common denominator. And I'm going to get 8/12, 10/12, and 9/12. So from least to greatest, I'm going to put 2/3, 3/4, and then 5/6. Now, the tricky part comes in if you're trying to do this using cross products, which a lot of people like to do that. They think it's going to be faster. And it is if you're just comparing 2 fractions. But when you're doing 3 fractions or more, you need to be sure that you actually compare all of the fractions to each other. So when I compare 2/3 to 5/6, I'm going to find that 2/3 is less than 5/6. So when I start to put my fractions in order, I know 2/3 will definitely come before 5/6. Now I need to figure out where 3/4 goes. I can compare it to 2/3, and I'll find out that 3/4 is greater than 2/3. Well, that means 3/4 cannot come first, but it could be greater than 2/3, or it could be greater than 2/3 and 5/6. I won't know until I compare 3/4 to 5/6. And this shows me that 3/4 is less than 5/6, so it has to go between 2/3 and 5/6. All right. If we look at another example, if I want to put 1/2, 2/5, 9/20, and 3/4 in order from least to greatest, try this one on your own. When you're done, hit play. Pause while you're working. When you're done, hit play, and then see if you've done it correctly. All right, 1/2, 2/5, 9/20, and 3/4. When you have more than 2 or 3 fractions to compare, if you can use a common denominator, that's probably going to be the best way if you can come up with one easily. This one, you should be able to see 20 pretty easily. So 9/20 can just stay 9/20. 1/2 will be 10/20, 2/5 will be 8/20, and 3/4 will be 15/20. So that becomes pretty easy to put in order. If I'm going least to greatest, I'm going to put 2/5, then 9/20, then 1/2, and then 3/4. Now, just as a side note, what I sometimes do before I start putting them in order is I will look at my 4 fractions, or however many fractions there are, and I will compare them to 1/2. I know that 1/2 is exactly equal to 1/2. I know that 3/4 is greater than 1/2, so it has to come to the right of it. And I know that 2/5 and 9/20 are both less than 1/2. So really all I need to do is compare those two. And then I can put this in order. So sometimes just using my number sense is helpful. All right, another example. If I want to put 1 2/3, 2 1/2, 1 2/5, 1 3/10, and 2 4/9 in order from greatest to least. That's a lot of numbers. But hopefully you see that 1 2/3, 1 2/5, and 1 3/10 are going to be definitely our smallest ones. Now that means 2 1/2 and 2 4/9 are going to be the first two, because the whole number is bigger. The 2 is bigger than the 1. If I think about 2 1/2 and 2 4/9, you probably know that 2 4/9, that 4/9 rather, is less than 1/2. So that tells us that 2 1/2 has to come first, followed by 2 4/9. If you didn't know that, you could have compared the 1/2 to the 4/9 just to be sure. And so that shows me 2 1/2 comes first, and then 2 4/9. Looking at the other 3, I might look and say, well, I know that 1 2/3 is more than 1 1/2, and the other 2 are less than 1 1/2. So I know that 1 2/3 is going to be my next one, going greatest to least. And then that leaves me with just 1 2/5 and 1 3/10 to compare. So if I compare the 2/5 and the 3/10, I can see that 1 2/5 needs to come next, and then 1 3/10. All right, one last question to think about. Pause while you read this one and try it, and then see if you were correct, and then hit play and see if you were correct. So if the numbers below were ordered from least to greatest, which number could go in the blank? Well, when I look at this, I know it has to be a number that's less than 3/10 but more than 1/8. When I look at these, it can't be 4/5 because that's more than a half, and both of these fractions are less than a half. So then when I look at my other options, I want to find which ones are greater than 1/8. So one fifth is definitely greater than 1/8, so it could be 1/5. 1/3 is definitely greater than 1/8, so it could be 1/3. And 2/5 is also definitely greater than 1/8. So I've not eliminated any of my choices. Now I need to compare each of them to the 3/10. I have found that 1/5 is less than 3/10, so it could be the 1/5. If I compare 1/3 to 3/10, 1/3 is more than 3/10, so that can't be right. And then compare 2/5 to 3/10. 2/5 is, whoops, made a mistake. 10 times 2 is 20. So 2/5 is greater than 3/10, which means it can't be that one either. So our only possibility is 1/5. All right, hopefully you're feeling comfortable with comparing and ordering fractions now. And it really is that simple. Honestly, again, knowing your multiplication facts and your division facts is the best thing you can do to do